In this video, we're going to give our robot some eyes and give him something to detect. So where we left off last time, we created some code to transfer spoken text into written text, so we kind of developed the ears of our robot. What we're going to do now is we're going to start our main project file, because we don't just want to have like just a whole bunch of scripts running individually from each other. We want to have some sort of central program that controls all of our features, and that sort of distributes information around, so we can use that to form behavior. So to do this, I'm going to make a new file, call it animal.python. And first of all, I'm going to define a main function, because that's what I do. And for now, we will just do something here soon. Then we also need to start that main function. We want to talk a little bit about this object detection that we need to do, specifically detecting the dog. So I came across a really cool, a cool video and then a very cool project. The video is by Siraj Raval, who I'm sure most people by now have heard of, who are into machine learning and artificial intelligence, because So I came across the video by Siraj Raval about YOLO object detection, you only look once object detection. And this seemed like a perfect candidate for us to use for our robot vision. So after looking around for a bit, we find out that this project is based on the Darknet framework. So Darknet is a framework written in C and CUDA that is a sort of a general neural network framework on which you can build your own projects. And the guys who did the YOLO object detection algorithm built it initially in Darknet, and then later on it was ported in such a way to TensorFlow via the Darkflow project, so we can use it in Python, which is great. So we need that as well. What we need to do is to clone this repository. We can actually go back one step. I already cloned it, but in any case, let me remove it. So we go git clone, put our URL in there. It's going to take a little bit. Take the contents of this folder. So we put it here in Darkflow, and you can. I think you can. Well, let's leave the license in there, but you can get rid of these things. And then here in our project, we just dump it all in there. Right, so what I need here is a new class to take care of the eyes bit. We call it eyes. Obviously, it's just sort of taking care of visual information. So now that we have the Darkflow project in our directory, we can import it. we need to import build from TFnet, and that is the TensorFlow port of Darknet that we'll be using. And we import OpenCV as well. I'm on OpenCV 3, I believe, but it's still CV2 for backwards compatibility. They didn't rename that. So we start a new class. We initialize, write an initializer for this. And in there we define the options for Darkflow. And we need to set the model. Now, I'll show you that we need to download from this website. Go away. From this website, you need to download this configuration file and this weights file. At least that's the one I'm using at the moment. You can experiment with other ones, but those work really well for me. So, and then here you configure those files. And then we create an instance of TFnet. And we pass in those options. Okay, then we write a new method we will call detect. And this will give us back an array of all detected objects. Or in this case, a few more into Python. I think you might be calling it a list. So you get back a list of all the detected objects, and in there we will have hashes with the details about those detections. And I think in Python we call hashes dictionaries. In my mind it's still a hash. So from TFnet we call this function return predict. And we pass in the image data that we will collect soon, and then we return that result. Okay, so let's just in here do a couple more things. We need to do some imports as well. First of all, we need our eyes class, import eyes, yeah. And then we need to import CV in here as well, OpenCV, because we are going to start a webcam capture and then pass in some frame data. So let's make an instance of eyes, and let's open up a capture device, and we do that by cv2.video capture. And then if you pass in 0 here, it will just take the first detected capture device on your system, which on a laptop will be your webcam most of the time. And just for debugging purposes, we will also define a font we can use on the screen later. Okay, and so we need to start a infinite loop, so while true. We have a return value and a frame value, which comes from cap.read. So we read the next available frame from the capture device here. And then we want to store something in detected, which we will use the method that we defined on our eyes class. And we pass in the frame data to detect. So what will happen is this method is called. This will now be the frame data that we pass in here, that we are getting from our capture device here. And it will then return predictions from the Darkflow code. Now we will loop over that array. So this comes back as an array of hashes like this. Let's just make that, and it will have some keys in it, like the label, and the label will be dog, and then there will be something like top left, and that will be on itself a hash again of like X, and then some pixel value, Y pixel value. So we want to loop over that array, and that means we're looping over all of our detections. So 4D in detected. Let's draw a rectangle around what we've discovered. So now finally we pass in a color value in RGB, so let's just make it green, and a line thickness right there. And then let's just also put some text on the screen, CV2, so we know what we are detecting. And then finally, we want to be able to exit this program now, so we put in a wait key, so it waits for a certain key press to be true. So now when we press Q, we break out of the while loop, and then we want to show the image on the screen so we can see what's going on. Finally, let's not forget to release all of our hardware and destroy all of our windows. Alright, so let's have a quick look if that works. I need to switch my Python over to Python 3 and go into the right directory, and then let's run that. Now, the first time you start this script up, it will be a little bit slow because it's loading all the weights for the object detection and the configuration file. So it'll be a bit slow in the beginning, but then once it's running, it won't have to load that again, so it will be a lot quicker. What's going on over there? I've seen that before. I know what that is. Actually, no. I do know what that is. So what we haven't got at the moment is the correct configuration and bin file. So what I will do is take that from the other project that I was referencing, because alrighty, let's see if that works. Alright, and we have a problem. It's Hershey, not Hershey. I wonder if there comes a day where we do a video and like everything runs on the first time and there's no mistakes in typos. Alright, this is strange. I did change it. Hershey. It has to be right. Very strange. Alright. So we can see that, okay, it sees TV monitor, it sees person. Now, I know why. We need to do one more thing. So here's the thing, that array that comes back that we talked about before with the hash in it, and then the label. So in this case we saw person. It has another key, which is confidence, and that will have a value, a floating point value of like 0.8. If I had a dog in the picture and I would show the dog, it would have like a 0.8, quite high. It does have TV monitor in it as well, but it will be like a 0.1. So I think the trick and the cutoff point would be somewhere around like 0.3. So like, let's say that if we did like if the confidence I wonder if that comes in a floating point value. I actually don't know. Let's try something real quick, and then you can see that hash as well way better. Let's just print detected, have it run for a little bit, and then you'll see. I always forget that with Python 3. So again, it's like starting up. It should just start printing like a crazy person. Okay, so here you see that array of detected items, and so here's that confidence key. Here you see like you have the label person, which would be me, the confidence, which is actually quite strange, 0.1. I wonder if that changed later. Person confidence 0.9, yes. So so what we want to do is this, like if the confidence larger than 0.3, then we want to put a rectangle. Let's try that. See, so now like a lot of the mess is cleaned up because it's still Sol TV monitor, but okay. Person is working quite well at the moment. I mean, I don't know why the Back to the Future poster is a TV monitor, but apparently it is. We can probably tweak that by putting the detector, even the confidence threshold even higher. So let's do that, and then also yeah, like we have to talk a little bit about the horrendous frame rates, because this is a real problem. So let's just take that up to 1.5 or 0.5 and see, and then we'll talk about the frame rate, because the frame rate is a real issue. Like now, even in the best of circumstances, Darknet, the YOLO implementation on Darknet, an actual C, and CUDA, on a Titan X, it has the potential of running 40 to 90 frames a second. Now, I'm on my laptop, which does have a GPU, but it only has 2 gigabytes or 4 gigabytes or something, I can't even remember. Like, it's nothing. So that already, you can tell, delivers a lot of lag, and obviously I'm also still screen recording, so that will help a little bit. But the problem is that on a Raspberry Pi, or not that we're going to use a Raspberry Pi, but I'm just saying that as a general term for a mini computer, for a single board computer, the one we're going to use is going to be a lot more powerful than the current Raspberry Pi. But even so, it won't have a GPU strong enough to make this run in real time. And so, while this is going to be our basis for recognizing objects, specifically the dog, because, you know, our robot is going to interact with the dog, we might have to make a concession. Like, either we run on a lower frame rate, which is probably what we're going to do. We'll just like have to sacrifice frame rate. Like, we're not shooting video on the camera, we're just using it to interpret real world data. So we can lower the frame rate a little bit and not have too much problems. Well, I mean, you know, it's either this or we have to stream the data somehow to a more powerful computer. We'll see. That might be something cool in the future. We'll just stream the data, we'll build a computer that can handle some real workload, and we'll throw it in the cabinet or something and just stream data to it from the robot. But that's for the future. Like for now, this is going to be the basis of our so next video we'll probably look into a little bit of interaction design and behavior design. So now that we have ears and we have eyes, basically, we can look a little bit at like how can we use this data to make some cool stuff happen. And then as soon as next month begins, like, well, we'll have to wait for parts a little bit. We'll be actually building the hardware unit itself, the robot itself. And that's going to be really cool as well. And the next video, yeah, I mean, should be out on next Sunday. Like, I'm trying to do it every Sunday to release one of these videos, so let's hope that that can continue. Thank you for watching, and yeah, I hope to see you next time.